Welcome. Let's continue with trigonometric formulas and identities. And we're going to look at product to sum and sum to product. So let's start right off here with a product, meaning something's being multiplied, becoming a sum, and the formula for that. So we're going to have the sine of 2x and the cosine of 3x. And we're to change that so it's a sum or a difference instead of a product. So we don't want it as multiplying. So the first thing for this is to recognize that we see 2x as theta and 3x as beta. We do that because of the formula for these. The formula for sine alpha cosine beta is equal to 1/2 the sine of alpha plus beta plus the sine of alpha minus beta. We get that from the list of formulas. I have one here. We'll go and take a look at these. Okay, so we are looking at a product to a sum. And what we have is a sine and cosine. So it's this formula that we're looking at right now. And this is in the section product to sum formulas on this paper. And there's a bunch of them. Notice that they're set up so that in this case it's sine and cosine, sine alpha, cosine beta. If it's both sine or both cosine, they're different formulas. If it's cosine first and then sine, it's a different formula. The differences look minor, but they're pretty major when you recognize that sine and cosine are not the same. So let's take this formula for this problem. All right, what we're going to do now, since we recognize here that alpha is 2x and beta is 3x, in fact, they'll say alpha equals 2x, beta equals 3x, we'll put that in those places here. So our next step is sine, the alpha is 2x, the beta, I'll put those in blue. I put these in blue. So now that's 2x plus 3x. And then 2x minus 3x. So let's simplify that. 1/2 sine of 5x and then sine of negative x. All right. Oh, there's a plus in there. Hold on a moment. I just realized that when I copied this down, I did not keep that plus going. And then I need to do it again here. Oh, I had enough room. Plus sine of minus x. Now, this one's an interesting thing. Okay, let's go back and let's take a look at the formulas. And we're going to look at the even up formulas. So in that part, it shows that if you have sine of a negative angle, that negative can go in front instead of with the angle. With cosine, it actually goes away. And with tangent, that acts like sine where the negative goes in front. But we have this one right now. So sine of a negative angle means that negative can go in front of it. As a result, then we're going to take that negative and we're going to put it in front. And so now what we have is 1/2 sine 5x minus sine x. Okay. And here, the easier way to show the 1/2 is underneath. Okay, so this is actually the best answer. We can't do more because we can't actually combine those together because 5x is inside it and x is inside it. If it had been 5 out here, we would have had 5 and no x here. We would have had 5 take away 1, so it would have been 4. But since the placement really matters in this kind of thing, and so it's sine of one thing, take away sine of another, apples and oranges type of thing. You can't actually subtract them. You just put them next to each other here. And then with the dividing by 2. So I'll go back here. It was cosine. No, it was sine. It was sine 2x cosine 3x. Sine 2x cosine 3x. So this product, multiplying those two, becomes this adding, which is actually subtracting. And remember that adding, or subtracting rather, is just adding the opposite. So we have done our job there of taking a product and changing into a sum or a difference, in this case, a difference. Now, let's do this one where we're doing the opposite. We're going from a sum and we're changing it to a product. So in this case, that's minus, which is a difference, not a sum. But let's just be careful that the linguistics doesn't bother us here, because subtraction is actually adding a negative of whatever that number is. So if it was like subtracting 5, you're actually adding a negative 5. So subtracting is actually adding. It's just adding the opposite. Therefore, we're going to still think of this as adding an opposite, but we'll still call it minus because that makes the most sense to us. So now let's go back and look at the formulas here where we're going from an adding or subtracting down to, or changing it to a product. And those ones are here. So a sum, oh, wait a second. I went the wrong way. That's for another one. It's this one here, from a sum to a product formula. And a sum means that, or it's adding the opposite, or adding the opposite. So we're going to be, in this case, we have a subtraction. I forgot which one it was here. Let's go back. That's a cosine minus a cosine. So we have a cosine minus a cosine. And that means we're looking at this one down here. All right, so we're looking at a cosine minus a cosine. And we're going to have a negative 2 sine, and then alpha plus beta over 2, and then a sine again, alpha minus beta over 2, and it's multiplying. All right, so let's go back to this, and now let's set that up. This formula, okay, so I'm going to first do cosine of alpha minus cosine. Let's make that a good deal neater. Cosine alpha minus cosine beta. Formula for that is negative 2 sine alpha plus beta over 2 times sine alpha minus beta over 2. And now we can put the things in, since that's 9x and that's 7x. Now I can rewrite it and put those two things in there. So it's alpha is 9x, beta is 7x. Alpha is 9x, beta is 7x. So it's negative 2 sine 9 plus 7 is 16, or 16x over 2. Sine of 2x over 2. Negative 2 sine 8x. And then sine x. Well, it doesn't look to me like we can do it any differently. Sine 8x sine x. So cosine of alpha minus cosine, oh, I didn't mean to put alpha and beta this time. I meant to put 9x minus the cosine of 7x. There. The whole thing yellow. The actual answer is this part. We can't actually do more with it because the 8x and the x are like inside the sign there. But you still can see now we just boiled it down to that. And that's as far as we can go until you can tell me what the x is. All right, let's take a look now at practice, a couple of practice ones. So it's sort of the same type of thing, but we're going to practice these. So this one is a multiplication product, and we're going to change it to a sum or a difference. Right? So here is alpha, and here is beta. That's equal to 1/2 sine, it's alpha plus beta, plus sine alpha minus beta. And And that's equal to 1/2 sine 4x plus 7x plus sine 4x minus 7x equals 1/2 sine 11x. Now, this one, okay, plus, do it step by step here, minus 3x. But this negative can then go over to the plus and go in front. So we will have 1/2 sine 11x minus sine 3x. And that's acceptable to stop there, although I prefer to have it over 2. Sine of 4x times the cosine of 7x. That is now a subtraction, or rather a difference, instead of a product. This would have also been acceptable with a half in front there. Okay. In fact, I'll put a box around that just to show that that would be acceptable. So that's a product being turned into a sum, or in this case, a difference. The next one is taking a sum, or a difference, it looks like, and making it a product. All right, so that case, again, we'll see 3x is alpha and 9x is beta. And the formula for that is 2 cosine alpha plus beta over 2 times the sine of alpha minus beta over 2. And that formula, again, that's sine minus sine. Let's go on up here and see, way back up here. Okay, so sine minus sine, now we're using this one, and that's cosine, then sine, and it's plus and then minus. So back down here, it's cosine and then sine, and then plus and then minus on the inside. Okay, so now we'll take 3x and 9x and put that in place of the alphas and betas here. 2 cosine 3x plus 9x over 2. And then the sine of 3x minus 9x over 2 equals 2 cosine 9, 10, 11, 12x over 2. And this one looks like it's negative 6x. Let's see. Maybe 3, 6. Yeah, 6x, isn't it? Negative 6x over 2. So that makes it 2 cosine 6x and then sine negative 3x. Now remember about that negative, they could go in front of the sign, which actually means in this case in front of the whole thing. Negative 2 cosine 6x sine 3x. And that's what sine 3x minus sine 9x is. Is it sine and sine? Yep, it was. It was sine and sine. So we can't go further with this because the 6x and 3x cannot be added or multiplied there. But we have simplified it down as much as possible for it. Okay. So those are 4 examples. Well, 2 of them for changing from a product to an adding or subtracting, or taking out some a difference and changing it to a product, like in this case, like we just did here on this one. Now, let's do some verifying of identities, and we'll be using this. So we're going to work on one side. We're going to take the sine x and sine y one. Because this is an adding one, we can change it. You notice over here, there's nothing in between them, which means it's multiplying. So let's see if we can change these adding and subtracting ones into products. So we can do that. This is alpha and this is beta. And for the bottom one, that'll be its alpha and its beta, same in this case. So when you have a plus 1, that's going to be 2 sine x plus y, or alpha plus beta over 2, times cosine x minus y over 2. And that comes from up here. We come back to this. So if we have, I believe, what, actually now I've forgotten already which one that was. So that's a sign plus sign and a sign minus sign. So back on the list of formulas, the sign plus sign means we'll use this one here. And sign minus sign is going to be, so we can use this one, it's this one, and we're going to use this one. Okay, and that means sine, cosine, and cosine sine. Let's get back to it. Ooh, lots of moving on all these pages. So that one's sine and cosine and plus and minus there. And on the bottom, because now we take this one and put it here, and that one's 2 cosine x plus y over 2, and sine x minus y over 2. Now, what we're going to do, we need to make those that y better first. Y over 2. Now you can see it's a y. Okay, notice that first the 2's will cancel out, but this is sine and cosine. Sine over cosine of the same thing is tangent. And then on the second one here, we have cosine over sine. Cosine over sine is like the tangent upside down. Tangent upside down is cotangent. And we can only do this because these two inside parts, theirs are the same. Oh, guess what? That's the answer here. We've just done it now. That's as far as we can go because x plus y, well, we don't know what x or y is, so we can't actually add them. And the same with subtracting. So this is now as far as we've been able to go. I just realized that with an S there. I shouldn't. Okay, so it's cotangent. And we got this because of, like I said, sine and cosine is tangent, and cosine to sine over sine is cotangent. And it just so happens that the tops and bottoms of those parts are the same. So we've just verified it because here is the other one. So that now these are equal to each other. We've got tangent and tangent, cotangent and cotangent, plus and minus. And we've just verified then that this is correct. And all we had to do was use the formulas for sum or difference change in the product. So now let's look at this next one. Okay, we're going to save this. And so now on this next one, cosine 4x minus 2x over sine 2x minus sine 4x equals tangent of 3x. Once again, now we have two differences here. So our goal is going to be to change that one to a product and change that one to a product. Okay, so it's really a matter of making sure you watch the rules, go back to the sheet of trigonometric formulas, and the cosine minus cosine will be this, -2 sine alpha, which is 4x, plus beta, which is 2x, over 2, and then sine again, and now it's going to be 4x minus 2x, alpha minus beta, over 2. And on the bottom now, that's where the second one goes. When sine minus sine, the formula is 2 cosine 2x plus 4x, so it's alpha, so it's beta plus alpha over 2. And then sine, and here it's beta minus alpha, which means it's 2x minus 4x over 2. So the 2's go away. I have minus sine, and that's 4 plus 2 is 6. 6 divided by 2 is 3. So this one's 3x. And then I have sine 4x take away 2x is 2x divided by 2. That makes this just sine of x. On the bottom now, the cosine of 2x plus 4x, which is 6x, divided by 2 is 3x. And then I have sine 2x minus 4x is a negative x. Oh, negative 2x, and divided by 2, I get a negative x. Well, this negative now, this negative here can go in front of the whole thing, but when it does, it cancels out with the top one. So we have no more negative anyway. Okay, so now what we have is sine 3x, cosine 3x, and sine x over sine x. Well, sine x and sine x, those cancel each other. And sine over cosine means tangent. What we have now is tangent of 3x. Oh, notice this. That's what we were trying to get to. So we now have matched. We now have matched the other side. And it's now verified. And notice, or remember the steps here. The first steps was simply using the formulas. And then it was getting these from the formulas and getting rid of getting rid of the 2's and getting rid of that negative, and then recognizing that that's tangent. Let's practice an identity, another one. So this one has cosine 4x. There's our alpha for that. And cosine 2x is our beta. On the bottom, that's its alpha and its beta. Okay, so the formula for the top one is cosine, it's 4x plus 2x, so it's alpha plus beta over 2, times the cosine of 4x minus 2x, so it's alpha minus beta over 2. And then the other one underneath it, sine plus sine, is 2 sine beta plus alpha, so it's 2x plus 4x over 2. And then cosine beta minus alpha, 2x minus 4x over 2. Hope you're with me so far. I'm just using the formulas that are, if this is a plus 2 cosine, then it's cosine times cosine with alpha plus beta and alpha minus beta inside. And here on the next one, it's beta first before alpha and the insides. But the sine adding 2 sines, we get the bottom formula. Well, now let's simplify these numbers here. Okay, so that's cosine. I'll do a different color going to the next one. That's equals that equals cosine. Oh, I forgot to put the 2 here that went for the first formula because now those 2's cancel out. So now we have cosine of 6x over 2, which is 3x. And then cosine of 4x minus 2x is 2x over 2. Well, and that's just x. Okay. On the bottom, we have the sine. 2 and 4 is 6, 6x over 2, that's 3x again. Let's make this more readable. Okay, so we get a 3x here. You can see where that's going. And on the other one now, this is cosine of negative 2x divided by 2 is negative x. But remember that if it's a cosine of a negative x, then we don't actually even use that. So what I'm going to do now is to emphasize that, I'm going to rewrite that. So that's 3x, and this is x. And that negative, you actually just don't do anything now with it. That just comes out, and so we get cosine of x. So these two things cancel out, but the cosine over sine, well, sine over cosine would be tangent. Since this is cosine over sine, that's cotangent of 3x. Oh, well, now notice something. That's what we were trying to get to. So that cosine of 3x we have now verified that these two sides are equal. Okay, and we did that through a number of techniques. First, using the correct formulas. Okay, and then just simply adding and subtracting these. And then it meant dealing with that negative, since it goes away there. Instead of cosine negative x, that's just cosine x. And that got us down to cotangent of 3x, which is what we were trying to get to in the first place. Yay. All right. So here is using these formulas to make the two sides of the equation. First, we don't know if it's really an equation, if it really is true, but it's working with one side of it to get it the same as the other. And sometimes we can use these formulas as part of it based on the clues we're given, such as adding two cosines or adding two sines. All right. Well, I hope that this helped to understand and remember what to do for changing to a product or changing to a sum or a difference. Thank you for watching and listening.